So we're going to begin with a little bit of introduction about descriptive and causal comparative designs. This part will mostly take care of the descriptive parts. So descriptive research is exactly what it sounds like. You're just describing the condition of something that you're looking at. For example, in schools, you're describing the condition of third grade math scores or the condition of seventh grade math scores. And we rely a great deal on these in education because people tend to want to know a lot about how things look. We can also describe the current state of affairs across multiple campuses. So if you think about the board report on campus performance, you're not only describing what is happening at one campus, you're describing what happens at multiple campuses. The tendency also is for that situation is people not only to know what this group looks like, but how does that group compare to other groups? So that's kind of the second half of this, is not only what we see here, but what that looks like in comparison to other groups, with the assumption that there's no other variation in those other groups. And that's the kicker on a lot of this, is that people will compare one school to another, yet they won't take the time to determine what are the other things that these students differ on. And what those other variables are really has a lot to do with why we see differences in the first place, which is really difficult to work through. So longitudinal studies are of four types. There are trend studies, cohort studies, panel studies, and cross-sectional. So a trend study is something that's a different sample is collected at each collection point over several years, but the population changes. So the easiest example of this, I think I mentioned in the book, is the NAEP scores. And what they will do is they will go into schools every year across the country, and they will take a sample of those scores. So what that population looks like changes because they won't go back to the same schools year after year after year. They're just trying to get an overall picture of how we're doing. So there's always going to be some variation in the population because it changes, which means our sample changes. Another example is a cohort model where you select a different sample from the same population, but you make a selection each year. So that means the population is constant. So think about within your own school system. If you wanted to say something about third graders and how they do, your third grade is your population, but each year you're going to take a different sample. The other one that people tend to do is something called a panel. This is where you select a sample from the population and you use that same sample for each year. So what that means is you're following a group through. So you take third grade and you look at what they're like in fourth grade and again in fifth grade. So it's the same sample from the same population year after year after year. Now, we realize this is going to change because the cohorts change, especially when you leave a campus. When the students from fifth grade leave and go to their respective sixth grade campuses, which may be different, or you're combining multiple elementaries, your population all of a sudden has changed. So you kind of have to reboot and say, okay, now this is our baseline for sixth grade. The last type is called a cross-sectional study, and this is where we want to mimic one or more of these. And we do that by selecting multiple samples that look like they grew up. So we'll take, if we want to know something about the NAEP scores, then we will pick out the third grade, the fourth grade, the fifth grade, the sixth grade, the seventh grade. And we're trying to compare them over the exact same measure like they grew up. And we could just follow them like we do in a panel, without actually having to follow them. This has a lot of downsides to it because you're losing some growth in terms of those people actually changing. You're assuming that everybody's changing at the same rate. On the other hand, something like this, a panel, takes a long time to be able to do that. You get a better set of scores, but you think about a 5 or 6 year study, that takes much longer to go through. So that's kind of a longitudinal overview. So the causal perspective means that we want to know if there is a difference between groups. So very often, because of the nature of our work, we can't always conduct a true experiment to see whether or not what we did made a difference. Because in a true experiment, you have to have a randomly assigned group, you have to have a treatment, and you have to have an experimental group and a control group. And you're going to apply this treatment to a randomly assigned experimental group and see if what you did made a difference. Very often in schools, we can't do that because we just don't have the resources to do it. We don't have the time to do it. There's ethic issues that we run into that we can't get that done. So therefore, we need a causal comparative situation, basically indicating we kind of did an experiment in hindsight. So we still need groups. How many do we need? It doesn't really matter. We have a system in SPSS that allows us to compare anywhere between 1 and however many groups that you can possibly think of. How do these groups need to differ? For now, what we're going to deal with really has to do with one variable. And what we mean is we need an independent variable and a dependent variable. What impact does the independent variable have on some dependent variable? So this has to work under some assumptions. So we can compare types of data. We can compare scores, incomes, attitudes, perceptions, whatever, between one or more groups. And we can do that because we have multiple types of tests that we could utilize. But here's the things that we really have to keep in mind. And this is absolutely critical, especially when it comes to choosing a statistical test. And this will keep popping up again and again. You've seen this before. These are the types of data that we want to compare. These are the types of comparisons we want to make. So I'm going to go through a few of these, but basically for us to make this determination, which side of this are we in, this column or one of these other 3 columns, comes down to this. Do we have interval or ratio data? Meaning, do we have real numbers? Do we have a normal distribution? Do we have a large enough sample? And are the score variances equal? And that can be corrected. But basically what we mean is, you remember back to our discussion about leptokurtic and platykurtic curves, positive and normal skewness. If the 2 groups don't look the same to start with, then you either have to make a correction to that, or you have to use a non-Gaussian distribution. You have to use one of these tests, and that is a decision that you get to make. Sometimes you can make an adjustment. You can get rid of some positive or negative skewness, adjust it, and everything looks fine. Sometimes you can't do anything about it. But what I want you to remember from this is if it's real numbers that are normally distributed, that means we're going to use independent t-tests. One way to know is Pearson correlations. If it is not that kind of data, if it is not a normal distribution, if you don't have a large group, if they're not equal, you've got to pick one of these. That's what these tests are for. And that is one of the biggest mistakes I see people make, is they think, well, I've got 2 groups and I've got surveys. Well, I'll just use this because I know what this is. That's the wrong test. And if you go back to one of the first videos I showed you, you can make a mistake by picking the wrong test and saying something that's true that's not. So if any of these conditions are not met, then what? Again, we go back to that middle column. Those 4 conditions, these 4 have to be there all the time to be able to use anything that is under these measures, all of them. If they're not, you got to pick one of these. So we're going to look at some examples of those causal comparative tests in our next video, and also I'm going to provide several other videos that show examples of what those actually look like.